Hello, I'm here today to talk to you about diesel particulate filters, or a DPF. So what is a DPF? Well, actually the clue's in the title there, diesel particulate filter. So we're talking about something that exists on diesel engines and something that acts as a filter, taking the particle matter out of the gas stream. So it's a filter. It's a filter in the same way as an air filter or an oil filter kind of operates. That's what it's supposed to do. It's taking the particle matter, or the soot most commonly, out of the gas stream. Doesn't sound so sophisticated, but it's actually quite a new technology. It's been introduced as part of the Euro 5 legislation and standard that the EU governments have been adopting on the original equipment manufacturers. So we in the aftermarket have to follow and adapt to meet these new criteria. And part of that includes the adoption of diesel particulate filter. So whilst it's new today, you will start to see this much more prevalent within the aftermarket. In many ways, a parallel there from the introduction of CAT 15 years ago. The catalytic converter was once new, but now it's everyday and everybody's comfortable and familiar with it. DPF is going through the same kind of journey. So a diesel particulate filter is a really important function and component within the diesel engine now and the diesel emission system. So if we just quickly recap on the diesel CAT, we all know that diesel engines always run lean. They operate in a two-way mode, cooler than a petrol CAT. The normal emissions gas temperature on a diesel is about 300 degrees. At idle, that perhaps drops to about 100 degrees. And regeneration, which is a really important topic which I'll come to a little bit later, regeneration occurs at around 650 degrees. I mention those numbers now because it's just useful to hold on to them. So before the advent or the introduction of diesel particulate filters, what we used to see was the taxis and the buses and the wagons running around on the roads emitting plumes of black smoke. And essentially what that black smoke is the soot from that diesel burn. With the introduction of Euro 5 in 2009 in the aftermarket, what we're now seeing is the requirement to manage that emission, that particle matter, to clean the airstream and try and help control and contain that soot particle to stop it being emitted into the air. Since Euro 5, what we're now finding is every few years that standard is becoming more and more stringent, and actually we're having to manage that gas flow in a much more particular way, a much more effective way, cleaning that gas flow. So let's go back a little bit. If we look at the introduction of CATs, what we were trying to do then was manage the hydrocarbons, converting those harmful gases into something less harmful, most commonly treating carbon monoxide and taking it to carbon dioxide, as well as managing some of the nitrous oxide gases, the NOx gases that we see some discussion about, particularly with VW at the moment. What we're dealing now with the introduction of DPFs is the management of that particulate matter. And later, as we start to talk about selective catalytic reduction, we'll come back to those NOx gases. And what we're trying to do is offer a complete package of technologies managing those gas emissions. So a DPF looks at managing the particle matter, trapping that soot, and it's actually successful in trapping about 95% of the soot that's created through that diesel burn. So manufacturers are being driven to get ever more sophisticated in their approach, but the basic principle there is the same. Different ways of going about it, but actually the aim, the function of the DPF is the same. So it's essentially a soot trap. It's a filter, as I said, like any other filter. The problem and the difference between a DPF and an air filter or a cabin filter or an oil filter actually finds itself more centered on cost than on function. So if you think of an air filter or an oil filter as just a regular annual service item, it costs very little and is easily replaced. The key differential with the DPF is that cost. It can be many thousands of pounds to replace this technology. That's not something that people want to add into their annual bills. So what the vehicle manufacturers have tried to do is build a system that becomes self-maintaining, self-cleaning in other words. So As the soot is trapped within the filter, what we try to do is manage that soot through a burn, a regeneration, which allows the DPF to become self-maintaining, self-cleaning, and extend the service life of that DPF. Now, there are different technologies, there are different ways of achieving this self-maintaining technology. Primarily, there are two systems. One is a thermal system, generally favoured by the German brands of BMW, Mercedes. And then there is also the fuel additive system, where an additive, airless PAT fluid, is used to reduce the burn temperature within the DPF, allowing that regeneration to occur more easily at lower temperatures than might otherwise be necessary. This tends to mean that the different technologies have different requirements and actually different service intervals. So if you think about a good thermal system on a BMW, for instance, typically the service life of that application might be 100, even 150,000 miles. Whereas on some of the fuel additive systems, generally favoured by some of the French marques, the service life of those applications tends to be closer to around 80,000 miles. So to quickly recap, a diesel particulate filter is a soot trap. It's there to fill with soot and then manage that soot in a way that doesn't compromise the performance of the vehicle. The gas temperature under normal operating circumstances in a diesel engine is around 300–350 degrees C. Regeneration, which allows the soot to be burnt away, occurs at around 650 degrees centigrade. So we need to manage that process to allow that component to become self-cleaning, self-managing. So if we think about the gas flow through this monolith, what we're seeing is that the gas will enter through a cellular kind of construction, and the soot will be trapped at the end and the gas will emit through. So over time, that soot will build up until it's about 50% full. So if you think about this technology in some ways like a tea bag, it holds the tea leaves inside, allows the water to pass through. It's not particularly sophisticated stuff. It's just how the car and the engine management manages that situation of that soot trap, allowing it to clean itself, that actually provides the sophistication. But it's not actually that much in terms of sophistication. It's a simple filter. It's a physical filter, just like that oil filter, just like that air filter. The problems occur when this filter becomes clogged, and that's where we just need to take steps to try to avoid the situation in the first place, but diagnose the reasons for why those problems may occur. The way in which we can avoid a DPF filter becoming clogged is through a process we call regeneration. Now, this is just a natural consequence of the engine looking after itself and the emission system looking after itself. So what we'll see is a sensor before and after the monolith. And the engine management will take the readings from those sensors and look at the pressure differential between the two. And when it recognises set limits has been reached, it will identify that the filter has become approximately 50% full. And at that point, it will trigger a burn. So what we will try to do is generate a burn within the emission systems to burn the soot away and leave a residue of ash. Now, there's a number of ways in which that regeneration can occur. And most commonly, particularly with high mileage motorway users, what we will find is there is a passive regeneration. So this is something that occurs quite naturally when the car is used at hot temperatures over distance and time. There's sufficient temperature within the exhaust system anyway to burn that soot away at a temperature around 650 degrees. The heat is already there within the system, and the soot, as soon as it accumulates, it will burn. So it will manage itself. Now, that system's great, that passive regeneration is great when your normal driving style allows that to happen. Unfortunately, not everybody does lots of motorway miles. Not everybody runs the car hot enough and long enough to generate those temperatures under normal usage. So what we will find sometimes is that the car's engine management has to take over, and it performs what we call an active regeneration. Now, an active regeneration occurs where the engine management identifies that the DPF is becoming full because of the differential between the fore and aft pressure sensors. And the engine management will identify that, okay, now is the time, now is the right time for that engine burn, that DPF burn to occur. So it will stimulate the conditions that allow that to happen by holding the temperature within the exhaust system. It might even inject some fuel into the exhaust system to stimulate that burn. Other ways you might identify this as happening is if you have a stop-start car, you might find that you come to the traffic lights and actually the engine doesn't cut out, that it maintains tick over. Again, that's the engine management showing signs that it's running some processes, it's running some systems unknown to you. And one of those systems, one of those processes could be regeneration. And it's just holding the temperature there within the exhaust system, continuing to tick over to allow that burn to complete and finish. The more extreme and third possibility in regeneration is what we call a forced regeneration. Now, this is a garage process where the driver has identified through an engine management light, or even in extreme situations, the car presenting itself in limp mode, where it starts to shut down and run on a restricted kind of performance basis. They will come into the garage with a problem with the vehicle, and most commonly, let's say, an engine warning light. Now, this occurs where the DPF has become very full, maybe 90% full, in which case passive regeneration clearly hasn't been happening, and for whatever reason active regeneration hasn't been allowed to occur. Now, there may be many reasons why active regeneration hasn't been allowed to occur. We'll come on to that in a moment. But basically what's happened over time is that the DPF has now become full, and it's created a clogged system which is inhibiting the performance of the vehicle. It's worth perhaps trying a forced regeneration in this situation, but actually the functionality of the DPF under such circumstances is so severely restrictive that it might actually be beyond repair and require replacement at that point. But using diagnostic tools, you can perhaps request a forced regeneration. And this is a functionality that exists but should be treated with some caution, because it's building such extreme temperatures through that exhaust system to try and encourage that soot burn that you can have adverse reactions and the car can actually become inflamed. So it is something that's actually quite risky and should be performed only under strictly controlled situation. It's not something to undertake lightly. It's actually so extreme that now some vehicle manufacturers are actually removing that functionality, and they're actually forcing it to go to a main dealer where they can try to undertake forced regeneration under strictly controlled circumstances. So it is a function. It's becoming less prevalent and less readily available, and actually if you're getting to that kind of situation, then you really need to be looking at the reasons that the car has got itself to that position as much as you should be looking to try to remedy or fix the situation. Okay, so let's look at why regeneration perhaps doesn't occur. There's not an awful lot to go wrong with the DPF. It doesn't have a lot of moving parts, and actually when it tends to show signs of failure, it's doing its job. It's trapping that soot, it's becoming full. So again, like the cat, in many ways it can be the victim of faults elsewhere, and what we need to do is actually diagnose where the fault really lies. So one of the key questions we need to ask ourselves is, why has it failed? Let's not just assume a replacement is the answer. So, if a DPF is becoming full, and it's becoming full of soot, then that suggests that regeneration isn't occurring. That can either be down to user, driver style, or it can be down to some kind of physical, mechanical kind of fault. Let's look at that. Mechanical fault within the DPF and the lack of regeneration could be a signal of poor service history, poor engine management. Could be faulty pressure sensors, oxygen sensors, sticky EGR valves, air leaks, condensation within the system, A damaged exhaust system can also present itself as DPF fault and lack of regeneration, whether high back pressure or low back pressure. It can have repercussions elsewhere. Incorrect oil and contamination within the exhaust system or within the DPF can also contribute, as can some seemingly silly faults. So lack of fuel within the tank can actually prevent regeneration. You need at least 20 litres within the fuel tank to allow regeneration to occur correctly. Regeneration itself takes about 20 minutes, so if the car isn't running hot and long enough, then again regeneration is not going to complete. Engine management lights. If there's something at fault elsewhere within the engine management, that can actually prevent regeneration occurring as well. So look for the reasons why regeneration may not be happening. Is there a good, healthy running car elsewhere? Has it been serviced and maintained correctly? Is there any signs of physical damage within the system? Eliminate as much as possible, and then you can likely fix the fault and allow regeneration to happen quite naturally within the passive or the active regeneration mode. Of course, you've also got user error, and driving style can have a major influence on the outcome and the health of that DPF. It used to be a bit of an old wives' kind of myth, take it on a good blast down the motorway or to the seaside. It's true, if you're running to the supermarket or just doing the school run and the car's not operating for more than 5 miles or 10 minutes twice a day, then the circumstances for regeneration to occur just aren't there. So the soot will be building up because the engine's in use. It's just you're not allowing the system to clean itself by creating the conditions. So neither passive or active regeneration will occur in that mode. So driving style and usage can be a major influence here. So we've looked at how a DPF operates. Perhaps at this point it'd be useful to tell you what kind of materials are used and how an aftermarket DPF can differ from an OE DPF. One of the things that we have to try to do within the aftermarket is produce a product to a price point that users are comfortable with. Unfortunately, with the DPF, the original can be very, very expensive, and there are good reasons why that is, but it becomes so expensive that the temptation in the aftermarket can be to avoid the technology rather than to try and embrace and use the technology. So, if we look at an OE DPF monolith, we can see that it's made of a material called silicon carbide, and we can tell that because of the cellular construction that we see in the diagrams and on the sample. This is a great material. It really is very good. It has excellent thermal properties. Unfortunately, it's actually very expensive to make. So whilst it's an excellent technology, it's not necessarily something that we want to use within the aftermarket. If you recall, we talked about regeneration occurring at around 650 degrees Celsius. This material is good to about 2,500 degrees. So in many ways, it's over-specified for what we need within that emissions burn. So fantastic technology, perhaps a little overkill. What we tend to find in the aftermarket is a material called corderite. Now corderite is already in use in the aftermarket. It's the substrate, it's the material that we use most commonly in catalytic converters. But it too has excellent thermal properties. This material is good to about 1300 degrees. So it's more than twice as capable of dealing with the normal operating temperature of the burn, the regeneration burn in a DPF. It's cheaper, it's easier to use and make, and it's got excellent thermal properties. So I would suggest that this is an excellent compromise, allowing the aftermarket quite legitimately to change from the way OE does things, to offer an aftermarket alternative that doesn't compromise performance in any way, but allows us to compete at a price point more acceptable to you. There is a difference between the way a CAT and a DPF operates. If we think about a DPF as a filter, it traps the soot, so it holds the soot in place. A CAT is a flow-through device. So in a CAT, we're looking to create a lot of surface area using a very concentrated cell per inch. And then within that surface area, we're using precious metals to act as a catalytic reaction. A signal of that comes in this browny, yellowy appearance. That signals that it has a good healthy loading of precious metals. Those precious metals are very, very expensive. A DPF has the same material and the same kind of construction, but generally the cells per inch a little bit more widely spaced, and of course, acting as a filter, the ends are blocked. It's white in appearance, and that signals in its raw condition, in its raw colour, this is not coated. It's one of the differences between the CAT and the DPF. So we've explained a little bit about how a DPF works. It's important to recognise that this is a legal requirement following the Euro standards adopted by the EU. Early incarnations didn't necessarily require type approval. So what you will see is some Euro 4 filter-only applications that are not type approved. But everything that's combined with a catalytic converter or Euro 5 onwards absolutely must be type approved and is type approved under an EU regulation R103 in exactly the same way as catalytic converters. Remember, type approval covers emissions. It does not cover capacity. One further compromise that we sometimes see within the aftermarket relates to the capacity or the size. So if we talk about these monoliths being expensive, a key part of the functionality of a DPF, one temptation would be to reduce the capacity, limiting the space available for us to use in filling up and filtering that soot. But perhaps that is a compromise too far, because that will compromise the performance of the vehicle in efforts to achieve those cost savings and those price points. But in reducing the capacity within the monolith, regeneration is having to occur much more frequently because it's becoming full much more often. And if regeneration cannot occur for whatever reason, then the DPF will fill much more quickly, creating problems for the owners and for you in the garage trade. So remember, type approval is a legal requirement, but it tests the emissions. It doesn't test the internals. It's an MOT requirement as well as a type approval requirement that a DPF exists where it exists on the original vehicle. This is something that's fairly new, and in the early introduction of DPF technology, what we found, because this technology was very expensive, was when problems occurred, people were looking to avoid the additional cost. So we were seeing instances of people cutting the DPF out of the exhaust system and replacing it with an empty box or with a bit of pipe work, remapping the ECU and then driving away without this technology, emitting an awful lot more particle emissions, 95% more particle matter than would otherwise have been emitted. That was perfectly legal because there was no legislation around this technology on introduction around 2009. Since then, however, the MOT has required a visual check so that if the DPF was installed on the original vehicle, it now has to be installed within the vehicle for it to pass the MOT. If it's not present, it's a failure and somebody's looking at a healthier bill. It's a visual check at the moment, but I would argue that in the same way as CAT technology became more commonplace and the testing of the CAT technology became much more sophisticated, so this visual check on the MOT will become replaced and built upon by something much more advanced and stringent. My message really is try not to avoid this technology, It's not going to go away. It's there for a reason. And the sooner that you embrace this technology, become comfortable with this technology, and make some good money out of this technology, the better positioned you will be. I hope this has been interesting for you. I hope you've learned something. Thank you for listening.